In the previous video, we covered the most common causes of wet or flooded basements. These include surface water intrusion, subsurface water intrusion, and sewer and drain backup. In this video and the next, we'll discuss how to keep your home's basement safe from water damage. All ground and landscaped areas along the perimeter of the foundation should slope away from the house and to an adequate distance in order to drain water away from the foundation. A swale provides a means to help divert hillside water runoff away from the home. If soil is brought up higher on the foundation wall in an attempt to remedy a slope problem, care should be taken to maintain at least 6 inches of clearance between the ground and the exterior wall material. Similarly, soil and landscaping materials, like mulch, should not cover brick veneer or the associated drain weeps if present. Be sure hard surfaces like driveways, patios, and walkways are properly sloped to drain water away from the house, especially those extending all the way to the foundation wall. Use sealant over backer rod, according to manufacturer's instructions, to seal joints where pavement or patios meet the foundation wall. Even an average amount of rainfall can cause problems if the home's roof drainage system is inadequately sized and poorly maintained. Downspout laterals should be sized and maintained to properly discharge several feet away from the foundation of the home. 10 feet is recommended by some home safety groups. Care should be taken not to discharge too close to the property line, as it may cause water problems for the neighbors. Gutters and downspouts must also be kept free of debris, such as leaves, twigs, needles, and seeds. And downspouts need to be connected and in place to function properly. There also needs to be an adequate number of downspouts of adequate size in order to handle the quantity of water being shed by the roof. The source of subsurface water can be seasonal, as when heavy rains occur and the water table rises, or it can result from a natural underground source, such as a spring. Either way, water will unexpectedly find its way into your basement unless you help direct and manage it. The first line of defense in directing and managing water intrusion is through waterproofing. Generally, waterproofing or damp proofing is applied on the exterior sides of foundation walls during construction. It provides a barrier, preventing moisture from being absorbed by the porous foundation walls, and acts as a drainage plane, allowing subsurface water to migrate down to the next line of defense, the perimeter drainage system. Sometimes, drainage material is applied over the exterior waterproofing material to facilitate the movement of water down to the perimeter drain lines. This is more common where subsurface water is a significant problem. The perimeter drainage system that collects the water below may consist of perforated or loosely fit tile set in place and backfilled with gravel, or it may be an integral drain line built into the concrete footing forms. These forms are simply left in place after the footing is poured to act as drain lines. In either case, the drain lines should run inside and outside the entire perimeter of the footing. This allows water to easily enter the drain lines, whether it exists below the basement slab or outside the home, and be conveyed to a sump pit. In some cases, if the house is located on a hillside, these drain lines may be discharged at a daylighted outlet at a lower elevation, rather than to a sump pit inside the home. When homes with basements are equipped with sump pits for collection of the perimeter, below slab, or in-basement drainage, they require the use of a sump pump to lift the water from the sump pit to above grade level. Proper sizing, installation, and backup of the sump pump are important. Sump pumps should have a means for backup. Some sumps are equipped with emergency battery backup in the event power is lost, but they only provide backup in the event of a power loss and not if the pump or its switch encounters a problem. Ideally, there should be 2 pumps, a primary and a secondary pump. The primary pump provides everyday pumping using the home's 120-volt electricity, and the secondary pump provides backup pumping in the event a mechanical or electrical problem occurs with the primary pump. The secondary pump is also powered by the home's electrical system, but equipped with a battery backup system that is charged by the electrical system when the power is available and transfers to battery when the home power is lost. This type of pump is often accompanied by an alarm system that provides an audible and visual indication that the backup pump is or has been in use. Water-powered sump pumps are also available and can be used as either the primary or as a secondary backup. Perhaps the most common failure modes for sump pumps are power failure, switch failure, or obstruction, an undersized pump, a frozen discharge line, and old age. Care and maintenance of sump pumps and their backup systems is very important, as is proper initial installation. Be sure to check manufacturer specifications on upkeep and battery life to ensure your unit is functioning properly. Simple measures, such as installing a sump pit lid or protecting the discharge line from freezing, may also help prevent system failure. Sump lids help keep foreign objects out and restrict pumps from moving, both of which can cause a switch obstruction and prevent the pump from starting. Where subject to freezing, special discharge line terminations and other measures may help prevent the line from freezing closed, which would result in an overworked pump and motor failure. In our third and final segment, we will address avoiding basement water damage through the prevention of sewer and drain backups.